We talk a lot about the y-intercept of a function, and so you might wonder, do all functions have y-intercepts? Well, let's think about that for a second. So if you think about the coordinate plane, and you think about the y-axis, the question is, do all lines cross the y-axis? Because if they cross the y-axis, then they're going to have a y-intercept. And you might say, no, well, there's a kind of line that does not cross the y-axis. For example, a vertical line will never cross the y-axis. But remember, a vertical line is not a function. So since the only lines that don't cross the y-axis are vertical lines, and since those are not functions, that means that the answer to this question, do all functions have y-intercepts, is absolutely yes, because every line that's a function must cross the y-axis somewhere. We talk a lot about the y-intercept. You might wonder, well, what about the x-intercept? All right, so let's talk about the x-intercept. So when you think about the coordinate plane, and you think about the x-axis, the x-intercept of a line is the place where it crosses the x-axis. And what do we know about the point where a line crosses the x-axis? We know that its coordinate will have to have a y-coordinate equal to 0. And so in order to find the x-intercept of a line, you simply substitute 0 for the output variable for f of x or for y and solve for x. So let's take a look. Find the x-intercept of this linear function f of x is equal to 1/2 x plus 3. So what we're trying to do is we're trying to find the value for x for which the function value y is equal to 0. So we have this equation 1/2 x plus 3 is equal to 0. And we'll go ahead and solve this. So we'll begin by subtracting 3 from each side. And then to finish this off, we'll multiply both sides by 2. And so we have a solution of x is equal to -6. So this line, f of x is equal to 1/2 x plus 3, would have an x-intercept at x is equal to -6. In other words, the line is going to go through the point -6, 0. Let's do another example. Find the x-intercept of this linear function, f of x is equal to -2x minus 1. So again, we're trying to find the value for x for which f of x is equal to 0. So we have 0 is equal to -2x minus 1. And again, we'll just go ahead and solve this equation. So 1 is equal to -2x, and we'll divide both sides by -2, and we have a value for x of -1/2. So the x-intercept is x is equal to -1/2, or another way of saying that is we know that this line passes through the point -1/2, 0. We already talked about whether all linear functions have y-intercepts, but do all linear functions have x-intercepts? Okay, well, let's think about that. So another way of asking that question is, do all lines cross the x-axis? And if you think about that for a minute, here's the x-axis. Can you imagine drawing a line that doesn't cross the x-axis? Well, sure. Any horizontal line will not cross the x-axis. And is this horizontal line a function? Yes, it is. It's a function. So in answer to the question, do all linear functions have x-intercepts? That answer is no. Horizontal linear functions that aren't the x-axis do not have an x-intercept. So let's talk about the equations of those special lines, the ones that are horizontal and the ones that are vertical. So horizontal lines have equations of this form: f of x is equal to a number. In other words, f of x is equal to 5, or f of x is equal to -2. Vertical lines have equations of this form: x is equal to a number. So in other words, x is equal to 7, or x is equal to -4. Now, sometimes people get nervous about, how am I going to remember which is which? So you don't have to be nervous about that. You can always draw yourself a picture and figure it out. So for example, suppose you were looking at a horizontal line and you knew it passed through the point, say, 0, 2, and you were asked, what's the equation of this line? Well, all you have to do is find some other points that are on the line, and it'll be real clear what the equation is. So for example, this line would also cross through 1, 2, and this line would also cross through -1, 2. And when you look at these points, what do they all have in common? They all have in common the same y coordinate. Oh, so then we know that the equation of this line has to be y is equal to 2, or in function notation, f of x is equal to 2. And so you don't have to worry about memorizing. You can memorize it if you'd like to, but you can also just derive it from a picture. So horizontal lines and vertical lines, one thing to notice is that there's only one variable in their equation, f of x, or in other words, y, or x. Okay? All right. So let's take a look at this one. Graph x is equal to 4. And again, this isn't something you have to memorize. I mean, you could remember, oh, that's a vertical line. But if you forgot, simply make yourself a table of values and put in some 4s for x. Notice it doesn't say anything about y, so you can put in any y values that you want. And then as you graph these points, you can clearly see, oh yes, that's a vertical line. All right? So why don't you try this one? See if you could think about the graph of x is equal to 7. Think about what that's going to look like.